Hello guys, welcome to the DMS online school. Uh, this is science paper 1 revision. So we are beginning actually the 20, we are starting the 2025 grade 12 internal revisions. So these are topic by topic revisions through examination papers. So if you want to be part of this revision, you need to join my online, and you have to WhatsApp me on 0977 92 41 75. This is the line, and actually it's not free. It's 120 to join the revision per month. So the amount you have to pay, it's 120 to join the science revision, which consists of physics and chemistry. Okay, so we have started and we'll be going through topic by topic just like that. Okay, so we have a question here which we need to look at from electricity. The topic is actually electricity. So let us go through this question together. Okay, so the question was A. It says figure 9.1 shows a network of resistors. So such terms like network, it just means like it is a connection. You have seen we have this figure here, which is figure 9.1. They're calling it a network because the word network is just a connection of resistors. We have this resistor here, and this resistor here. Okay, so before you start answering, you need to analyze the type of connection that you can see here. So in this circuit, the moment you notice that it has a branch, you have one root here, one path, then afterward the path divides into two branches. We have this path going this way, this path going this way, and this path going this way. The moment you see branches or two paths dividing, then you have what we call a parallel circuit. Okay, we have a parallel circuit there. So here we have a parallel circuit in this one. So we have a parallel circuit, and if we follow this route here, you'd find that we will meet resistor 3. Again, we'll meet resistor 3. So we have two resistance. So when passing from resistor 3 to another resistor 3, there is one path. So what does that mean? It means that these two resistors are in series. So these resistors are in series. Okay. So, however, when you pass the other route down here, you meet resistor 6 alone, 6 ohms. So in judgment, we can say these two resistors on top here, resistor 3 and the resistor down here 6 ohm, they are in parallel. So the two resistors on top, they're in parallel with the resistor at the bottom. Why? Because these two on top are in their own branch, and then this down here is in its own branch. So when they come here, they meet again here and it continues in one path. So when dealing with the circuits like this, you need to remember some of the rules. Some of the rules that you need to remember about. First of all, current. So you need to know some rules about current. So like here we have parallel. So current in parallel circuit. Parallel. So current in parallel circuit divides at the junction. So say divides at the junction. So current will divide at the junction, meaning you have seen this 6A. 6A is current, so you can read it as 6 amps. 6 amps. So you have 6 amps here. Now this 6 amp is current. So when current flows reaches a junction, some current will go in this top route or path, and some current will go in this down path. So let us look at the voltage. So again, you need to look at voltage in parallel. So what happens with voltage in parallel? So with voltage is the same across resistors in parallel. So what that means is this. So we have these resistors which are in parallel. So these resistors are in parallel. Okay. So the resistors are in parallel. We have these on top here, the 2 on top and then the 6 down here. They're in parallel. Now that they're in parallel, what does that mean? It means that the voltage across these 2 resistors on top and the resistor down here is the same. If you're able to know the voltage in this circuit, then you already know the voltage across the resistor down and then the resistor on top, because voltage is just the potential difference, how much voltage is coming here at, let's say, point A, and how much voltage is leaving at point B here. It's like pressure in a pipe. When water is passing there, it will feel some resistance. Then because of some resistance, the force will reduce. It's like the force, yeah. So potential difference is like the force pushing the water in the pipes. So the force at point A and point B will differ depending on the pressure or the resistance that the water may be facing. It also applies to current. So current also faces some resistance, and current is pushed by voltage. Voltage is a force that pushes current in a circuit. So there will be current passing here. Of course, as it will be passing on the top route, it will feel some resistance, and also as it will pass below the circuit, it will also feel some resistance. So those resistances that it is going to feel are what we call resistance or resistor. Okay, now let us look at the question first of all. So question Roman numeral 1 says, what current flows in the 6 ohm resistor? What current flows in the 6 ohm resistor? This 6 ohm resistor here. So you have 6, you have 6 amps, and that, as we said, current in this parallel divides at the junction. So when current is here, some current should go up there, and some current should go down here. Now, what would determine the amount of current which will go up and down is how much resistance it is going to feel. How much resistance it will feel passing here and also passing here. So you will notice that before you understand how much current resistance it will feel on top or down, first of all, let's know the total resistance which is in the top root here. Total resistance which is in the top root can be found. So these two resistors here, they are lined up in a straight line. So since they are lined up in the straight line, they are in series. And since they are in series, total resistor in series is just added. So like total resistor, like RT, meaning total resistor, is equal to, we'll just say resistor 1 plus resistor 2. Meaning this other one, we can call it resistor 1. This other one, we can call it resistor 2. Then we add them. So when we add, we'll say resistor 3 plus resistor 3. We'll get what? Resistor 6 ohm. Meaning that this upper root here has a 6 ohm resistor. But when we check here at the bottom, the down root also has got a 6 ohm resistor. Meaning that equal current should flow through these resistor. So if they say what current flows in 6 ohm resistor down here, it means that since we have 6 amps coming, it should divide equally. So since current divides equally due to total equal of resistance, if they were not equal, they will not divide. Understand me? It is because there is 6 ohm on top and 6 ohm down. So they are dividing. So it means that you get 6 divided by 2 because there are 2 branches here. It will be 3. So this will be the answer. So the current that flows through resistor 6 ohm is 3 amps. So if we go to the second question, the second question is this one here. What charge passes through the 6 ohm resistor for 3 seconds? So what charge? Again, you have to remember charge. So there is a relationship between charge and the current and time. So charge is what creates current. When charges are passing through a circuit, they create current. Okay? So when they say what charge and they've given you time, and then you also know how much current is passing through the same 6 ohm resistor, you have current I passing through that resistor, it is 3 amps. You have time given, which is what? You have 3 seconds. And then they're asking you what? Charge Q, which is an unknown. So looking at this data given, you must know a formula which relates the three of these quantities. A formula is current. Always remember current is equal to charge over time. This is the formula. I current, Q charge, T time. Now the question is asking you to find what charge, meaning Q in this formula. So make it the subject of the formula. To do that, you do this. Current is equal to, can let me write here, this part of mine doesn't write properly, I think. So let me show you from here. I said make Q the subject of the formula. So you start with Q over time is equal to current. Then since this side you have a fraction, also this side you introduce a fraction by just putting a mere 1. putting a mere one will not affect anything. Then you do cross multiplication. You say Q times this one down here, you get Q, which is charge, equals. Then you say time times current, T times I, it will be I T, like that. Meaning this is your formula for finding charge. Charge is equal to current times time. So you substitute, you say, okay, charge now is equal to current is 3. You say 3 amps times time is again 3 seconds. What do you get? You say charge is equal to now 3 times 3, 9. So you get 9. Then you need to add the units. Units in science are very important because they tell the type of the quantity you are dealing with. If I just put 9 here, it will not make meaning to anyone. But if I put C here, capital C, it will mean that this 9 can be read as 9 coulomb. So what is 9 coulomb? 9 coulomb is a charge. So this is the answer there. So you move on to the next question. The next question says, 3. What is the potential difference across the 6 ohm resistor? They are asking for potential difference. Potential difference is voltage. So they are asking for voltage across the 6 ohm resistor. They are saying, what is the voltage here? What is the voltage here? So, as we said, look at, we already talked about voltage. Voltage is same across resistors in parallel. So, like this, it will be hard for you to find voltage. If you just know the formula for voltage, for instance, we know that voltage is equal to current times resistor. Okay? So, if we go direct and say, okay, our voltage should be current going through here. Thank you, we already know current going through there. So current, we said it is a 3. Then resistor, 6. Then total, 3 times 6, it will be 18. 18 volts. Now, let's see if we can use the concept of saying voltage in parallel is the same. So we'll find voltage across this point and this point here. So to do that, we'll find total resistance in series, in parallel. So we have two, these two on top, they are giving us here, this one, and down we have here. So total resistance in parallel, is equal to resistor 1 times resistor 2 over resistor 1 plus resistor 2. So most of you know that total resistance, there's this other formula that we are used to. Total resistance T is equal to 1 over resistor 1 plus 1 over resistor 2. So this first formula and this second formula are the same, except this first formula has been simplified for you already. So let me show you. If we want to make this formula become like that one on top, we can just simplify it by looking for a common denominator, adding the adding these resistors in series. So which can be resistor 1 as a common denominator and the resistor 2 as a common denominator, where we'll say resistor 1 into resistor 1 times that one, it would actually okay, I think here we should be having something like this, 1 over RT. Okay, I'll see if I am correct or not. So we'll say R1 into R1, it will cancel, will remain with R2. R2 times 1, it will be R2, then plus, then R2 into R2, it will cancel, remain with R1 there. So here, yes, so here it should be over RT total. Then we'll just cross multiply here first. So multiply this RT times what is there. So say RT, open brackets, R2 plus R1 equals, then we'll say, okay, 1 times this R1, R2, it will be R1, R2. So now we are looking for total, so divide this side by R2 plus R1, even this side R2 plus R1, so that this one and this one cancel, remain with R total is going to be R1, R2 over R2 plus R1. So you see this formula and that formula, they're just the same. So it means you just go straight to using that. So our aim is to find the total resistance. So we'll say, okay, equals, we'll say resistor 1, which is 9, 6 times 6. Resistor 2 is also 6 over, then we'll have 6 resistor 2 plus resistor 1, 6. So we'll have equals 6 times 6, 36 over, then we'll say 6 plus 6, 12. Okay, so we'll say equals, so say 12 into 36, it will be 3. Okay, so R total is 3. So meaning that total resistance in this entire circuit here is 3 ohms. Meaning that if we were to find voltage now, total voltage will be equal to current, which is 6. Current passing there is 6. So it will be current 6 times resistor total 3. The answer is 18 volts, just as we found here already. So now voltage, as long as you know current and the resistor, it is easy now to calculate voltage. So in this question, where they said what is the potential difference across the 6 ohm resistor, as long as we already know the current flowing there, then it will be easy. We'll just say voltage is equal to current times resistor. Then you substitute, you say current is equal to, voltage, not current. So we'll say voltage is equal to current, which was 3, times the resistor itself, which is 6. Then our answer is going to be 18 volts. Just like that. Then we move to B. B, they are saying a 2 kilowatt 250 volt electric fire is connected to 250 volt mains. So there is an electric fire. This electric fire is like a device It can be like a stove, a fridge, a TV, which has been connected to a 250-volt mains, like they've connected at the socket there, and the socket is able to produce 250 volts. Now the information here, a 2 kilowatt, these are what we call rating. This is what we call rating. Rating shows how much power a particular device uses. So for this electric, they're telling us that for this electric fire, it uses a power of what? Of P is power of 2 kilowatts. Then it also uses 250 volts, that is volts, 250 volts. So meaning these are the ratings, that is what it uses. And when they say is connected to a 250 volt mains, it means it has been connected to the um, right voltage, so it will start working well. So they are saying, Roman numeral 1, how much current does the electric fire take? How much current? It's current. So if they're asking for current, so that's what they're asking for, current. So you have these three provided here. So meaning when you have a 250 electric fire that has been connected to a 250 volt mains, it means it is already using 250 volts there. And if they tell you that its power rating is 2 kilowatt, it means that it is already using power of 2 kilowatt. So this 2 kilowatt, it means 2000 watts. This K is a prefix which means 1000. So when you find a K, it is a prefix. Then W here, watts, it is read as watts, are the units for power. Then V is volt, units for volt. Then current, the units are A, amps. So looking at the question, how much current does the electric fire take? Using this information, power, voltage, current, look for a formula which connects these three. The formula is power is equal to voltage times current. Now the question is asking to find current. So make current the subject of the formula. Again, I said you say voltage times current is equal to power. You swap them. Then you are looking for current, not voltage. So you divide by voltage. You get rid of voltage. You divide by voltage. Also here by voltage. So that volt cancels. You remain with current is equal to power over what? Over voltage. So meaning your formula now will be current is equal to power over voltage. So this implies that you substitute power, you use this one, 2000 watts. So say 2000 watts divided by voltage, you use 250 volts. 250 volts. So what are we getting there? We are getting 8. 250 volts into 2000, you get 8. So this is current, so you put what? You put amps. So therefore, we'll say current is equal to 8 amps. Again, if you don't put the units, again that will mean that the answer will be considered wrong. Then we go for the next question, Roman numeral 2. They're saying, what is the cost of running the electric fire for 5 hours in the cost, if the cost of a unit kilowatt hour of electrical energy is 900 kwacha. The same, what is the cost of running electric fire? Like when you are using this electric fire for 5 hours, how much are you going to pay? So for you to answer this question, you must understand how electricity is sold. So electricity is sold in electric energy. So electricity is sold in what? Electric energy. So you must understand electricity is sold in what? In electric energy. So for you to know how much it will cost using this electric fire for 5 hours, you must know how much electric energy it will consume during those hours. So electricity is sold what? In electric energy. So electric energy, I'll put E. E. So that's the symbol electric energy we use. So you must first know how to find electric energy. So electric energy is equal to power times time. Okay? So if you know now, oh, electric energy is power times time, then how about cost? So I always abbreviate like cost of using electric energy is equal to electric energy you have used times what I call unit price or unit cost. You can say cost of electricity is equal to electricity used times U is unit, then C is cost. So meaning our formula now changes. So here we'll say, okay, to find the answer, we'll say equals electric energy used is given by this formula, power times time. So we have substituted this has been swallowed by these two because this means those two. So swallowed this brings these two here. Then these times it will come here. So these times you see here, it's for these guys, two of them that have come here. Then unit cost. Then what you do, you substitute power. Power is already there. So power, when calculating electric energy used, power should be in kilowatts as they've put it themselves. So you put 2 kilowatts times what? Times time. Time is 5 hours. So you put 5 hours there. Okay? 5 hours. Then times unit cost. Unit cost, they're saying cost of unit of electric energy is 900 kwacha. So this one should be 900 kwacha per kilowatt hour. Okay, let me just remove the other part here. So what you do now, you say equals. So you can see that this kilo and this can cancel. This watt and this watt can cancel. This hour and this hour can cancel. So now you just do the multiplication of 2 times 5 times 900. So 2 times 5 times 900. You get a 9,000. So that will be the unit cost. 9,000 kwacha. So this is the cost of using electricity. So cost of using electricity will be 9,000 1000 kwacha. So today we end here with this revision. Just as I said, if you want more of these revisions, you need to join my online tuitions at 120 for both chemistry and physics per month. So if you want to join me at or WhatsApp me on 0977 92 41 75. We have started. Let's join so that we can begin together to avoid remaining behind. So for now, guys, bye and see you in the next revision.